Record. All right. Hey, all right, over here. All right. Hi, my name is Joshua Zhang, and I'm gonna give a presentation about repelling by using principle of work energy in this example out here. So before we start the calculation and stuff, I'm gonna introduce what repelling is, the background and stuff. So based on definition that I found, repelling is to descend by sliding down a rope pass under one thigh, cross the body, and over the opposite shoulder or do a special friction device. So basically, you see a person out here. He's trying to sliding down rope from the heel. He's kind of grabbing the rope, so that way, it will reduce his gravity down to the ground, so that way he won't get hurt by holding a rope. Yeah. Now we're gonna watch a video about it for the fast rappelling. It's only for experienced jumper in the familiar terrain. All right. Not everybody can do that. It's pretty complicated. So he start jumping right now. 1, 2, and 3. It took him 3 jumps to get down the hill. All right. So what we are looking for right here. So the goal is calculate person's speed right before he finished his first jump. So remember we had 3 jumps out here. So boom, 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 3 jumps. So we're gonna calculate the speed of the person right before he finished the first jump. All right. So there's his starting position out here. All right, over here, and he start the first repelling. Pew. He dropped down over here. That's his ending position. Is right before he finished the first jump, and is same position when he started the second jump. All right. So givens. So in this example though, it's pretty hard to eyeballing, the exact uh the height and person's weight based on the video. So all givens assume are based on the video research and personal experience. I have been repelling a couple times, so I have some experience, I guess, to do some rough estimation. So the height of hill is 10 meters. Second jump, starting position is 6 meters. And the gravity pretty standard, right? It's 9.81, and tension rope is 100 Newton. This one is pretty random. I don't know how to make up a more standard number for that, but I guess kind of makes sense. The person's weight is 200 pounds, which is 91 kg, and the initial position, since the person haven't started repelling yet, and I guess his starting velocity should be 0, right? And for assume, same thing, all based on video research and personal experience. All right. So in this example, though, we're gonna neglect the air resistance, neglect the material failure of rope because of tension, because the rope will break at one point because the person's weight and his grabbing method, so he might tear the rope down and a lot of stuff could happen. So in this example though, we're gonna assume the rope is very strong, will not break under no circumstance. All right. And gravity 9.81 honestly is not so accurate, but it should be fine for this example. All right, next one. We're gonna apply for the principle of work energy. So which is T1 plus sum of U1 to 2 and T2. T1 is the initial kinetic energy, which is 0 in this case because V1 is 0. All right. And second one is the work uh the work applied on the person from position 1 to position 2. And T2 is final kinetic energy. All right. That's our free body diagram. So initially 0 kinetic energy and while he's jumping, we got the tension holding him up and the gravity holding him down. And I assume the final position, final velocity is kind of going downwards because velocity is, not velocity, my bad. The gravity is higher than the tension. So that's why he's kind of, descending down to the ground. And lastly, we got final kinetic energy going downhill, right? We just kind of plug and chalk based on the equation and all the numbers that we got. So basically, just like everything out here. Okay. And yeah, that's everything that we need based on the calculation that we have out here. Okay, we got the final velocity of 1.94 meter per second. And we do some result analysis with conclusion in this example. So we got final velocity of 1.94 meter per second right before the person land. And the final speed is 1.94. It's actually not so fast. And the jumper won't get really hurt based on the weight. And if he has proper landing skill, it should be totally fine. However, though, with a weak rope grabbing, it doesn't grab rope tight enough. The tension rope will reduce to hold the person up. So that person will actually get hurt by not doing, the grabbing position properly. And yeah, thank you so much for staying for my presentation. All right, appreciate it.